Hello there, this is another look at some further maths, year 12 discrete maths to be precise, and we're going to look at, well, it says Prim's algorithm there, and we are doing Prim's algorithm. We're also going to do Kruskal's algorithm, and we're going to do it in different versions. And what this is, it's an attempt to basically join up loads of dots. This is the least weight tree connecting all the vertices of a network. And what I said there is it's an attempt to join up all the dots on the network, so it's or graph. So for instance, if I draw some vertices, or sometimes called nodes, and I'll label them. There's A, there's B, there's C, and there's D. Now at the moment these are not joined up. The obviously C's different, so now I can join it up in a number of ways. I could draw it like that, or I could have joined it up from A to C instead, or I certainly don't want to draw there to there, because then I kind of I've already joined them up. I don't need an extra row. And so this is when it says the least weight, it basically means the way to join up all these vertices in the shortest amount of well, for instance, this might be a distance. It might be a distance I have to dig along a road in order to join up 4 different towns with cable TV. So the idea being we try to minimize those numbers. Now let's have a look at this process then. Kruskal's method. Now I shall show you that because that's basically what we're going to try to do. But what I suppose I really want to do then is just show you how to do it. So you're welcome to read all that, but let's just get in and do it. Now applies Kruskal's algorithm to this network, and what we're trying to do, this least weight thing, is usually called a minimum spanning tree. So we're going to try to join these up with the least weight. And as you can see, from A to D, I don't know what it is. It might be the distance I have to dig along that road I was talking about in these towns. And very often, one way of doing it is to, you do see this, where you list all the different versions. But there's actually, if you don't get asked to do that, you don't have to do that. But some people like to do that to show. So, for instance, CD is 5. The next number after that I can see B to D is 6. And you can write these down. But as I say, I don't really like doing it. But sometimes a question might ask you to do it. AB is 7. What we got? We've got DE is 8. But after a while, you get a bit bored of that, and you don't necessarily need to do it. But some questions I've seen, they expect you to draw this ordered list of arcs. I'm not going to do that as a general rule. I'm just going to look at them. And the thing about Kruskal's, you're meant to pick off the lowest one, the smallest arc, first of all. So you'll notice over here, I'm going to say AD is 2. So I'm going to write here, AD is 2. And so I find it useful then just to draw it. AD is 2. Then the next one, this is where this comes in. You see, you can tick that off. And then obviously the next lowest is BC is 4. BC is 4 is there. And you notice I don't really care where they are, as long as there's BC is there. The next one apparently is CD, which is 5. So CD is 5. Let's join them there. And the next one, it reckons, is BD is 6. BD was B. BD is all the way around there. Now, the only thing about BD, if I was to draw that one, can you see how that would make a, well, I'll draw it and then I'll get rid of it, because that would make what would be called like a loop or a cycle. And I don't really want loops or cycles, so I'm just going to get rid of that and then do what I was really wanting to do, which is to avoid cycles. So I'm not going to bother. I did BC, but I'm not going to bother with BD. Now AB is, if you look at it, it is there. That's that one there. Oh, that would make a loop as well. I'm not going to do that. I don't want that. DE is 8. Well, that's all right. DE is 8. DE is 8. Now, actually, if you just look at this, I've got 1, 2, 3, 4, 5 vertices. Now, that means 4 arcs is enough to know that I've fully joined them up. And, that picture has joined them all up. 6, 11, a total of 19, whatever. So it doesn't tell me what the units are. So now let's do a couple more of these. I'll do this first one. So again, I'm not going to bother with this ordered list of arcs. I'm going to look at it and just work it out. So my lowest one, you always pick the lowest one first of all, and that's BE. So BE is 2. And again, just draw a little picture so you know where you've been. Now, the next one looks to me to be the CD. CD is 4. That's at the bottom. Next one looks to me as if it's that one there, ED. ED is 5. How many arcs have I got? I've got A, B, C, D, E again. So I've got 5. I'll need 4 arcs. I need one more. So my next lowest one, I've done 5. Next one is 7. Now if I do that, can you see I'm going to have a loop there? I don't want that 7. I need basically to join up to A. And I reckon the easiest way to do that is that AB, which is 9. And I reckon that has joined up all my points. Dum, dum, dum. You can see they're all joined. I can get from one to any other one, indirectly, admittedly. So that's 6, 11, that adds up to 20. Let's do this other one. So this one is, look for this lowest one, I reckon UT is 1. So that's my picture there. My next one looks to me, I've got 2 3s. I've got PT, which is 3, and I reckon I'm going to very quickly do this other one, which is UR, which is another 3. So there. And what's my next one? I've got a 5 across the bottom, so ST5. So that goes across the bottom. I don't want to go up there. The next one is, it's probably that one there. It's that TQ, which is 6. And my suspicion is I've joined them all up. Look, I've got 1, 2, 3, 4, 5, 6 arcs. I need 6 vertices. I need 5 arcs, and I've got them. 4, 7, 12, 18. So this is Kruskal's algorithm. And you need to understand then that Kruskal's algorithm, you basically go for the smallest one. You keep adding arcs until you join them all up, but you're not allowed loops. And that's what all this was about. Do not let yourself have loops. Now, Prim's algorithm works slightly differently. It does exactly the same thing. It finds the least way to join up these vertices. It does the alternative way of describing it is a minimum spanning tree. So this minimum spanning tree, but it does it in a different way. What you do is you have to decide where you're going to start. And the question very often tells you where to start. It doesn't always. But you do it in the same way, really. Once you know where you're starting, well, I'm starting at A, and I look for the smallest way to join from A to another place. I reckon it's that AB is 5. AB is 5. Again, draw yourself a little picture so you know where you're going, where you've been. Now I've got A and B in my picture. I can go from A and B, the smallest one from either A or B. Now I've got a 10, a 9, an 8 coming off a 7. I reckon it's that 6 coming off there, which is the next one. So that is A to D is 6. Now notice I didn't have to go from B, which is where I've just joined from. I can go to anyone. And now again, I can join any point from A, B, or D. And I reckon it's just that 2 going across there. So what's that? DE is 2. Okay, how many vertices have I got? 1, 2, 3, 4, 5. I need 4 arcs, same as before. And now I want the smallest way of joining to this network. I reckon it's that one there, going from D to C. D to C is 3. Now 5 is 11 and 5 makes 16. Always try to remember to put your total. Now notice the way it has done the same job. It has joined them up. It just does it in a different order. And if they tell you to use Prim's algorithm, you better do it in this order. If they tell you to do Kruskal's algorithm, now go back to what I started with. Notice it again. It told us where to start. So I've probably got 2 more here. Yes, I have. So where's it say? It says start at A again. So starting at A, I reckon A, the shortest route is AE. AE is 1. Now, okay, a little picture. There's my picture. Where can I go from there? I could go down. Again, I think my best one is 5. ED looks like it's best. ED is 5. Now that's straight down on my picture. Where can I go from there? I can go 14. I reckon it's 7 there. A to B. So I'm going to go A to B is 7. Where can I go? Well, definitely down. B to C. I wanted that one. That's B to C. Now, how many have I got? It looks to me like there's 5, therefore I need 4 arcs. There's always one less arc than vertices. So what's that up? Oh, look at that. I wrote that down wrong. I just realised that was a 3 to start with. A to E was 3. 3 and 5 is 8. And I reckon that's 16. Hopefully I don't make daft mistakes along the way on these. Let's do this one. This one says start at M. I don't even know where M is. M is here. Shortest way from M, I'm going to draw this over here, is that MN. MN looks like it's 2. So I've drawn that. Now I can go from M or N. I've got a 6, I've got a 5. I reckon that N down to R looks like the best one. N down to R is 5. Now I can go from M, N or R. What's the shortest one? I've got a 9, a 7, and I reckon it's at 7. R to Q is 7. That's there. And now I want one more. That's obviously straight up, isn't it? You can see that P to Q up to there is 1. It doesn't matter if you call it PQ or QP or PQ. There was that 7, 14, 15. That adds up nicely. Okay. Now, we are sometimes asked to do Prim's algorithm from a table, and this is a different sort of way of doing it. It does exactly the same thing. Again, that is there for you to have a look at what it is we're doing, but again, it's always best just to see it in action. So here's it in action. First of all, then, we basically decide where we're going to start. It doesn't tell me where to start. I'm therefore going to start at M. So if I start at M, put a 1 above the M and cross out M. The 1 represents that that's where we're starting. And having crossed out M, I look down M and I look for my smallest number. And you can see it's actually a 6. My smallest number, if I look down M, is 6. So I'm going to put a circle around 6. And that was MR. So I write over here, MR is 6. It represents this part here, which of course, if they was to draw you the picture like I have here, I've been kind to you, you can see MR is 6. Sometimes they don't draw the picture for you though, so you can't see. You just have to use the table. So now I'm going to cross out, and this again, a bit brave, but cross out that, and I've crossed out R, so I'm going to put a 2 above the R. Now I can look down either M, I've just got a 12 down there, or 2, the R, the 15 and the 7. Now the smallest number of those 3 is the 7. So put a circle around the 7, that's Q. So that was Q to R. So Q to R is 7. Now, which, if you actually look at it, it goes to that picture over there. But you wouldn't know that, I suppose, if they hadn't drawn it. We're only able to do that because they've drawn the picture. So I've now got my 7, and I cross out now my Q, and I put a 3 above the Q. And now I can look down number 1, number 2, or number 3. And what's my lowest number? I reckon my lowest number is at 8. So that 8 is the P. PQ is 8. So I write over here, P to Q is 8. And up here it's there. That's that picture there. And having done that, of course, I now cross out P. I put a 4 above the P. And then I look down 1, 4, 3, or 2. I only want, and the smallest one's at 10. And so having done that 10, that's, notice is NQ. So, all right, NQ is 10. What's on the picture? Oh, it looks like that. I wouldn't have known that, but, you know, makes sense. And you look at that, you think, well, that's joined up. That's done exactly what I wanted it to do. Do a total for it. 6 is 13, 21, 31. And again, I do like to draw totals. So I'm going to try and do this one quickly. I'm going to draw the numbers in, and then we'll do it. So that's my picture, my table from that diagram, and I'm going to quickly try to do this. I'm going to start, doesn't tell me where, I'm going to start at Q. So if I start at Q, that's my number 1, and I'm going to cross out Q, and I'll look down that, and you'll notice my smallest number is 2. So QP is 2. And having done that, that was in the P, cross out the P, and look down the P, 2. So now my smallest number in either of those is the 1, and that's PT is 1. And I'm going to carry on doing this, and hopefully you're going to do it as well. And I'm just going to finish up, and I'll put my answers up, and hopefully you'll be able to say, yeah, I got the same answer as I got. And I'll pause it now. I suggest you do the same and then come back to this in a bit. So this is what I got. I got a total of 17. There's my arcs, there's my minimum span entry, and that's the two methods. Now notice there are two methods to do the same thing. They both give the same result, Kruskals and Prims. The question will tell you probably which one to use. Good luck.